Alrighty, this is the brand new unit for geometry. True story. I actually, as I'm recording this, I got out here to Prairie View at about 5 o'clock this morning, and I about 5:30, give or take, and it's about a quarter to five right now in the evening, and I spent pretty much the whole day recording algebra, recording their unit, covering their material and their stuff. Taking breaks for food and what have you. And I was planning on going home and just kind of calling it a day and coming back tomorrow to deal with this. Um, but then I remembered what this unit was, and I remembered that this was actually one of the units that I was really looking forward to teaching and really starting because it's all about triangles. And it's all about, and so I was like, oh, we're starting with triangles. Triangles are kind of the backbone of geometry. With the previous unit, we started doing proofs with triangles. We started proving similarity. We had theorems about similarity. Once we had similarity, we could use different theorems to prove different aspects of triangles, to solve for different variables and solve for different values and things. So now, this entire unit and the unit for the rest of the year is just about triangles. Triangles, congruence, everything that you would ever need to know about them, you're going to find we're going to find out about them with this unit. So first things first, we're going to start with their classification with the worksheets here. So if they have three acute angles, what is an acute angle? Actually, I'm going to get a new pencil. An acute angle is any angle that is less than 90 degrees. So if you have a so if you have a triangle where all three of the angles are less than 90 degrees, but they are not equal to each other, but they're not equal to each other, then you just have what's called an acute triangle. So it would just be acute triangle. And just for shorthand, every time I write this, that's just triangle. So if a triangle has an obtuse angle, what is an obtuse angle? An obtuse angle is any angle that is greater than 90 degrees. A triangle will ever only have one obtuse angle. It will be an obtuse triangle. Yeah, a triangle will only ever have one obtuse angle because if you remember, the internal angle measurement of a triangle is 180 degrees. Even if you go 91 degrees, which is just 1 degree over 90, which is like the smallest threshold, smallest realistic threshold for an obtuse angle, that means that you only have 89 degrees left in order to fill the internal angle measurement of the triangle. Well, at least according to Euclidean geometry, anyway. Um, so it'll be impossible to get another obtuse angle out of that. So again, there's only a possibility of one obtuse angle in it. If you have one right angle in a triangle, then it is known as a right triangle. And much like the obtuse angle, you can only have one right angle in a triangle because triangles, again, have only 180 degrees of interior angle measurements, and the right angle is 90 of them. So you can't really take another 90 because then you'd have like a weird looking straight line. So then that brings us to the three congruent angles. If you have three congruent angles, then that means that all three angles are equal. And I'm going to spoil it for you. That means that all three angles equal 60 degrees. That one is also called, that one is basically called, and it's across all the, you'll see. That one's just going to be called an equilateral triangle. Or I think they've thrown a new term like a congruent triangle, but if you just use equilateral, everyone knows what you're talking about. So those are the four types of triangles that we're going to be dealing with. And it has to do with, and we're classifying them based on their angles. So let's take a look, classifying each of the triangles below by their angles. Starting out with CDE. So I've got C, then D, then E. This looks like it's going to be a right triangle because from C to E, I've got that box right there with a perpendicular angle. So that tells me It is a right triangle. If I'm looking at BCE, well, C is clearly greater than 90 degrees. And so that tells me that based on this one angle, C is obtuse. And so if it has one obtuse angle, that means that this is an obtuse triangle. Excuse me. If we're looking at triangle ABE, so I got triangle ABE, I've got one angle equal to the other angle equal to the third angle. I mean, what else do you need? You got an equilateral triangle with each of these angles equal to 60 degrees. BDE, let's see. Going from B to D to E. So I'm looking at BE and ED. The angle at BED is definitely greater than 90 degrees because CED is exactly 90 degrees. And so because BED is obviously greater than 90 degrees, that makes it obtuse. That makes it an obtuse angle. And all you need is the one obtuse angle. I keep pointing at it, the one obtuse angle, in order to be an obtuse triangle. Finally, we've got Charlie Foxtrot Echo, where we have C, F, and then E. Well, it's like, so CDE is a right triangle. So CFE is less than 90. C and F, they're not equal to one another, but none of them is greater than 90. And so all three of them are less than 90 degrees. And so what that means is all three of them are going to be acute angles, but none of them are equal to each other. So that just means that we have, with this triangle, CFE, an acute triangle. Alrighty. So that is if you want to classify a triangle by angles, which is certainly your prerogative. I'm partial to the sides, which is what we're going to move to next. But you'll find out eventually as we go into triangle things that they're pretty closely related. So if you have three congruent sides, tell you what, you've got an equilateral. Honestly, I think when I go back up here, I want to say that this is called a congruent triangle. Um, but I've honestly never heard it called anything except an equilateral triangle, even when referring to the angles. I have personally never heard it called anything but an equilateral triangle because everyone knows exactly what you're talking about when you talk about it. So there may be another term for it, but um, you have my word that I'm not. But if you have my word that if you call it an equilateral triangle, I will not mark you off on the assessment or any of the worksheets. Oh, here we go. So that gives us an equilateral. That means that all three sides are the same. And so all three of the sides are the exact same measurement. So if all three sides are the same and all three angles are the same, and that refers to the same object, does that mean that the sides and the angles have a relationship, or there's some kind of a relationship between the angles and the sides? Yes, it does. It absolutely does. The angles and the sides are directly proportional to each other, relative to each other, they're directly proportional to each other. So if you have an obtuse angle like with BED, if you have with an obtuse angle like BED, the side opposite that obtuse angle is going to be the longest side in the entire triangle. So with BED, the other angles are EBD. That's this side here, not very long, and then the opposite side from D, not very long. But you have the opposite side from the angle E. It's the longest side with the obtuse triangle. So yes, there is a relationship between the sides of a triangle and the angles of a triangle, which is why whenever I heard equilateral triangle, it was referring to both the angles and the sides. So we'll move on from that. If you have two congruent sides instead of three, you have what is called an isosceles. triangle. You're definitely going to want to check the spelling on that. You have an isosceles triangle. Um, that means that you just have two congruent sides, which, as you probably guessed, means that you have two congruent angles. Um, and then depending on what the angles are, this side, you have two congruent sides, so you have two congruent angles. Let's see, if you have no congruent sides, then you have what is called a scalene triangle. And as you cannot say anything about the sides, so too you cannot really say anything about the angles. Relatively speaking, like I can tell this angle is smaller than this angle, so this side is going to be shorter than this side, and this angle is bigger than both of them. And so relative length, yes. Do you want to be, can you say that you can calculate it with any confidence, like with dV or dV plus confidence? Absolutely not. It's just kind of a reality check, or just kind of it's like, well, I did the calculations, I did the algebra, and I calculated that this side is what is measure of 2 meters, but this side is measured 10 meters. That should be a warning sign that you may have messed up the calculation. So let's see, classify each angle in the diagram by its sides. All right, so JKM. So I've got, all right, so the hashtags here are for a different triangle. JKM doesn't have any hashtags sharing it, so it is definitely scalene triangle. Excuse me. KLN, alrighty. With triangle KLN, I see that I have got KL and LN equal to each other. So that means I've got an isosceles triangle. I can't spell this very well even when I'm not on 12 hours of filming. So yeah, check the spelling on that. Did I at least spell it the same way? Yeah, okay. So at least if I spelled it wrong, I spelled it wrong twice. Then that leaves us to JKN. JKN, all three sides are equal, all three angles are equal, so equilateral triangle. All right. So that's how you classify them, by sides. Um, are you going to be expected to classify them by sides and by angles? Probably. You really should. I'll have to take a look at the assessment. I haven't really yet, but it's kind of intuitive. I'm not going to say yes or no at this stage, but it's not really asking a lot. So let's see, classify each triangle by its angle and its sides. All right. So let's see, by the angle, I can see I've got a 90 degree. So that's going to be a right triangle. By the sides, I've got two congruent sides. So that's going to be isosceles. I know what the word is. I know how to say it. I just, yeah. Let's see. So for A, so for this one, I've got obtuse. So for this one, the angle is definitely obtuse. So this one is an obtuse triangle. And then for sides, I don't have any markings that indicate that there are any sides that are congruent with one another. While I would agree with the little word, with the little voice that's in the back of your head saying, well, it looks isosceles. Just because it looks isosceles doesn't necessarily mean that it is. And unless you have these congruence markers, then you don't have it. It's one of those things, especially at this stage of the class, especially in this stage of your education, if you don't have these, then it's not there. So because it doesn't have these, I can say that it's an obtuse triangle by angle, and then scalene triangle by sides. All right, and then of course the last one is everyone's favorite, the equilateral triangle. All righty, so that about does it for Just Kidding, there are problems. All right, if ABC is an equilateral triangle, then solve for both x and y. Well, if ABC is an equilateral triangle, then that means that all the sides are equal. So what that means is 3x plus 1 equals 18y minus 41. But why would you want to do it that way? You have 49. Do 3x plus 1 equals 49. Don't, why would you want to set those equal to each other? Don't do that. That's weird. So 3x plus 1 equals 49. From here, I can solve for x. I can subtract 1 from both sides. So that gives me 3x equals 48. And I think that's going to be 6. I think it's going to be 16. Get my research assistant out here. 48 divided by 3 equals, yep, 16. And then for y, we'll do the exact same thing. So 18y minus 41 equals 49. And add 41 to both sides, so that gives me 49 plus 41 equals 90. Well, 18y equals 90. I'm pretty sure the answer is going to be 5. Divided by 18. Yep, y equals 5. And there we go. That's the answer to the first one. So here we are. If RST is an equilateral triangle, find x and the measure of each side. Oh, you jerks. All right. Okay. All right. So this is, if you thought the previous unit was mean as far as algebra was concerned, if you thought the angle relationships was mean as far as algebra was concerned, this is the first worksheet of the unit. They are not messing around with us here. So RST is an equilateral triangle. Find x and the measure of each side. What this means is we have to solve for x. So the thing is they're equilateral. So this is equal to this, which is equal to this. They're all the same variable. They all have the same variable, but thankfully they all have different values for that variable. So I'm going to set 12x minus 22 equal to 10x minus 6. Because it's an equilateral triangle, I know that I can do this. I know that 12x minus 22 equals 10x minus 6. Now what I'm going to do is I'm going to take 10x from both sides and add 22 to both sides. And that's going to give me 2x equals negative 6 plus 22 equals 16. So x equals 8. So I'm done, right? No, I'm absolutely not done. And as I record this, this is the day after the second formative assessment for the previous unit, and for unit 4. And a lot of folks, when they figured out the ratio, they got x equals 8, and then they said, all right, I got x, and then they moved on. No, the question is find x and the measure of each side. So with x equals 8, that means 12 times 8 plus 22. This side is 118. And that's it. There, because I don't have to go through, I don't have to go through each one of them. I just put 8 into 12x minus 22 and got 118. Why don't I have to check the other two? Because it's an equilateral triangle. All three of the sides are equal. I solved one, I solved all three of them. So that's your answer, 118. All right, let's see. Isosceles triangle with DE equal to EF. Find x and the measure of each side. All right. Let's see. Well, again, it's an isosceles triangle, and so the sides are going to be equal to one another. So 8x minus 13 equals 5x plus 17. I'm going to add 13 to both sides and then subtract 5x from both sides. And that gives me 3x equals 30. Yep. X equals 10. And then the measure of each side. All right, now this one is a little bit trickier because with the equilateral one, I was one and done. I was finished because they're all three the same size. With this one, I actually am going to have to work a little bit. So with this one, x plus 21, x equals 10, so this side equals 31. This side, because it's an isosceles triangle, this one side is going to be different from these two. Now, I figure out this one side, I figure out this other side, I'm done. But because it's an isosceles triangle, one side is going to be different, so got to do what I can. All right, so this one, 8x minus 13, that's going to be substituting x equals 10, 80 minus 13. That's going to be 67. And that's our answer. That's going to be the side. All right. Next one over. If WXY is an isosceles triangle, find the measure of each side. Boy, they like this type of problem, don't they? Well, again, if it's isosceles and we know what the two sides are that are equal to each other, we just set them equal to each other. 6x minus 77 equals 3x plus 4. And we're just going to solve, and we solve for x normally. So 3x equals, and then 4 plus 77, 81. X equals, I want to say that this is 17. Oh, 27. X equals 27. All right. So again, I found x. I'm very happy that I found x. It's quite the accomplishment. But the question asks for the measure of each side. And it's an isosceles triangle, so I've got to solve each of the sides. 3x plus 4 seems like the easiest one to go for. So 27 times 3 plus 4 equals, so this is 85. All right, we're done with that one. 5x minus 31, 5 times 27. I'm using the calculator off camera over here. Let's see, 5x times 27 equals that minus 31. So this one is equal to 104. And there we go. Isosceles triangle, so I solved this side. That means I've got this side. And then this is the odd man out, so I had to solve for that one too. All right. Well, now they're not even giving us a drawing, you jerks. And I can say that because I didn't write this. So I can call people out for being jerks on this one. All right. If PQR is an equilateral triangle, oh well, I guess I can do it this. All right. If it's an equilateral triangle, one side is 18x plus 1, the other side is 24x minus 7, and then the last side is 15x plus 10. All right. X plus 1 equals 15x plus 10. I guess there's no reason to have the drawing because all the pertinent information is in the thing. It's an equilateral triangle, and these are the equations for the sides. Again, when we're trying to solve for x in order to find the length of the sides, if it's an equilateral triangle, we can pick any two we want and then just solve for x that way. So it leaves me with 3x equals 9, so x equals 3. So now all I have to do is plug this in to one of these equations, and then I basically have the side. So 18 times 3 plus 1 times 3 equals plus 1 equals 55. There, that's it. Find the x. Oh, find the x. There we go. And oh, I forgot that. All right, each one of these says solve for both x and y. Solve for x. Find x. All right, there we go. I just went back and circled it because it did say find the x for some of the answers. So yeah, there we go. If it's an equilateral triangle and you solve for one side, you'd solve for all of them. So there we go. Let's see. STU is an equilateral triangle. ST is one less. Oh, come on, guys. All right. ST is one less than twice x. So 2x minus 1 equals 11 more than x. All right. So x plus 11 equals 2x minus 1. I just went with the easiest ones that I could read. So if ST is 1 less than twice x, so 1 less than twice x, so it's 2x minus 1. And then TU is 11 more than x, so x plus 11. Find x and the measure of each side. So subtract x from both sides. That gives me x equals, and then add 1 to both sides, 12. And again, we're dealing with an equilateral triangle, and this is just unnecessarily obtuse. I hope the assessment isn't like this. But all I have to do is plug this back in and plug this back into any one of the equations. Plus 11. Excuse me, I apologize. All I have to do now that I have x is plug it into one of these equations. I'll just use one of the ones that I've already translated. So x plus 11 equals one of the sides, so 12 plus 11 is 23. So that's 23. Side equals 23, and that's it. Now, because it's an equilateral triangle, again, if I solve for one side, I solve for all of them. Alrighty. MKL is an isosceles. Ah, dang it. Well, it was a good run while we had it. If MK is 7x minus 5, 15, and ML is 10x minus 42. All right. 7x minus 15 equals 10x minus 42. So why did I completely ignore 4x minus 5? Well, I read that MKL is an isosceles triangle, and then I read what sides were equal to what. And so what I read was MK and ML are the two sides that are equal to one another. If with an isosceles triangle, I know what two sides are equal to one another, then I can actually solve for x, which is what the problem is asking for. So MK is 7x minus 15. There we go. ML is 10x minus 42. There we go. KL I'll deal with later, but for right now I need to find x. So I'm going to subtract x from both. I'm going to subtract 7x from both sides. So that's going to give me 3x equals, and then add 42 to both sides. So that's negative 15 plus 42, 27. So x equals 9. So that's part of it. But now I've got to figure out what the two sides are. So again, because it's an isosceles triangle and I know that these two sides are equal, I only have to solve for one of the sides. And so I'm going to pick MK. So 7, 6, so side equals 7 times 9 minus 15. That's 7 times 9 is 63. 63 minus 15, which is equal to 48. So that's one of that's one of the side MK. Yeah, side MK is equal to 48, which means ML is also equal to 48. Now I'll look at KL, because now KL actually has something that I'm interested in, which is the final component of the problem that I need to figure out to move on. Is equal to 4 times 9 plus 5, well, minus 5, excuse me. That's 36 minus 5, which is equal to 31. And there we go. And so, yeah, it's the understanding and knowing triangle identities is pretty handy when you get some of these obtuse word problems. And here we are again with the last problem of the worksheet, but it's also it's also another word problem with an isosceles. So AB equals BC. So again, I've got an isosceles triangle, and I've got AB equal to BC, where I've got to find x. So what do I care about AC? I want AB and BC. I want AB and BC. So 3x plus 41 equals 8x minus 54. Let's see, I'm going to subtract both. So I'm going to do some algebraic rearrangements. So that gives me 5x equals 41 plus 54, which gives me 95. X equals, divided by 5, 19. So I've solved for x. Now I've got to solve for the sides. So side AB equals, so 3 times 19 plus 41. So I'm choosing just this formula. I could choose either one of these two formulas because they're equal to each other, as stated earlier on in the problem. But I just have to solve one of them, and then I get the value for both of them. Because again, isosceles triangle, these sides are equal to each other. So let's see, 3 times 19 equals 57 plus 41 equals 98. So two of the sides are equal to 98. Awesome. And then the last side that I've completely ignored, because I haven't needed to yet, is AC equals 12x minus 103. So side AC equals 12 times 19 minus 103. And that's just a quick cap assistant with my research assistant. 12 times 19 minus 103. That's going to equal 125. So there we go. That's our final answer. Boy, that was that's a heck of a first day, isn't it? But yeah, so that's 5.1, and yeah, like I said, that's a heck of a first day. We're going to keep the ball rolling with the next chapter and with the next thrilling ride with triangles.